demo application I have built using MeTTa. So in the morning session, we have covered what MeTTa is, how we can store knowledge or data using MeTTa, how we can query that data by writing some functions. And we have also seen how we can integrate our MeTTa using Python, using a Hyperon package. We have covered this in the morning session. So in this session, I will show you how we can build a mini application using MeTTa. So let me first share you my screen, and I will show you how I build the general idea of the application and how I build it using MeTTa. Okay, let me first show you how the application works. Then we will go over the code. So, do you see my screen?
Yes, we do.
Okay, so this is a mini application I built using MeTTa as a knowledge base and LLM to convert human text to JSON and to convert the MeTTa result into human readable format. And I have also used a Gradio to build a mini frontend. So what the general idea of this application is that, let's say we have a connection based on different categories. For example, I have friends, I have colleagues, and some other categorical relationship with another person. So I want to ask the LLM if I have someone who is a nurse in my connection, or who has a hobby of playing chess. So I want to, let's say, I want to ask, or I want to know that. So what this application helped me to do that is I can enter my question here in this text box. So by default, let's say my name is Alice. So this system helps me to find a specific connection from my network. I will show you the data in the code later, but let's see how this is going to work. So let's say, let me ask, for example, who in my network is a nurse. So I can ask this, the LLM, and it will check my connection and the data and return me. For example, it says Bob, Emma, and Helen are nurses in your network, and it also shows me the resource it used to answer this question. I can also add another question. For example, let's say, do I have someone who is a doctor in my network? Yes, it's answered yes. Liam is a doctor in your network, and it's also give me the relationship, the resource it used to answer this question. Let me add one more question. For example, let's say find a classmate who have a hobby of chess, let me say. So let's say I have classmates and I want to know anyone who had the hobby of playing chess. Uh, so it says I couldn't find any classmates of Alice who have chess as a hobby. Let's say this as let's say anyone. We can say anyone, not specifically uh, classmates. So it's answered me. Carol enjoys chess. So Carol is someone who is connected with me, or who is connected with me with some specific relationship. You will understand this when we see the data. So this is the general idea of the application. So uh, l- let me show you how I used MeTTa to query my relationship uh, based on category and uh, to build this kind of mini applications. Okay, you can see my screen, right?
Yes.
Okay. So let me go over the code and how I built this application. So I have like a number of modules. Uh, I have a data that contains my connections, not only my connections, but different people connections. So I stored this relationship, this connection in MeTTa, in MeTTa file, data.meta file. We have seen in the morning session how we can store some kind of data. You can say it's graphical data in this case, since MeTTa is some kind of graphical database. So we have a different category and the relationship between people. So let's say we have a friend category, and this two shows who is a friend of Alice, David, and so on. We have a colleague category relationship. We have a family, a neighbor, and classmates relationship. And I have also added two attributes that show the connection between people based on their attributes. Let's say in this case, in profession, Alice is an engineer, Bob is a nurse, Helen is a nurse, and so on. We have also a hobby. So uh, so this is my overall data. So by using this, someone can ask the who is connected with Alice, and the example questions we have seen in the application. So first, what we have what I have used to do this is that since LLMs are better at converting this kind of human readable or text question into a specific structured JSON format, I used a Gemini LLM to convert the text that which is prompt, or we can say the query, into specific JSON format. We can say that format schema. So the LLM helped me first to convert the question into specific JSON format, which is it helps me to categorize the subject. It can be a string or null. The relationship, in this case, the relationship shows it can be any, or it can be a friend, colleague, family, or neighbor, or classmate. And it also extract the target attributes, which is what I'm looking for. It could be someone with some specific profession or with specific hobby. So it helps me to extract the target attribute. And also I have added finally the maximum depths it can go to get that specific person or target. So in the first case, this specific file helps me to convert the user text or the user question into specific JSON. So then we convert this specific schema or JSON into a meta query by importing that specific JSON format. Then we convert that using we convert that specific JSON into a meta query. I will show you all the details, and then we run meta in the background. We we have seen this in the morning session how we can use meta in Python file using a Hyperon package. So I will come back to that later. So we take the meta response, in this case, which is the pattern matching or the query, and we give it back to the LLM. Then that LLM help us to format in human readable format and answer the user that specific question. We have also added we to include the information the LLM used to answer that specific question, because we don't want some hallucinated answer. But for example, if we need kind of fact check, we can add the resources the LLM used to answer that specific question. So in this file, this is my main app. I have a number of functions in this file. This specific function helps me to force the depth of the search. For now, I have only limited the search to go to search for direct relationship. I have also the main function, which is chat with the LLM, or we can say RAG. So in this main function, first I have a parse question to JSON. So we have assumed the application is built for Alice. So we pass the subject as Alice, and this helps us to return the JSON, the formatted JSON. It transforms the query or the text into specific JSON format that we specified before in using the schema. Then we pass this specific JSON to the find by JSON, which we find this function. This function help us to convert that specific JSON to meta expression. Then we get that answer from the meta. Then we finally pass this result as a context for the LLM. So this is the general step I follow to build this application. Then we compile it, all these steps, into one LLM prompt. So we say you are a helpful assistant. User asked that we give it the question, and including the structured JSON query. Then we pass the answer as a context. Then finally, uh, we tell we tell the LLM to answer a human readable answer based on that specific context. So in this section, I have just used a package called Gradio just to build front end. So this is just the front end part. I have a row and a column. In the row section, I have text box and two buttons. In the column sections, I have the answer output and the source output. So this is a general step or function I have used to do this. So let's see to the main functions that help us to do this, which are parse question to JSON and find by JSON functions. So this parse question to JSON function just converts that specific question into a JSON format. So we pass the subject, which is Alice, and we pass the schema as a context. We also pass the subject here, assume subject, which is Alice in our case. This call function pass this prompt, and what we are doing in this call function is that we pass the prompt, which is the specific schema and the subject, and this function help us to call the LLM. I have already set up the Gemini 1.2 Flash model here. So we need some, we have to integrate, we have to import our Gemini API key and so on. So I have already set up, I have already defined that here. And so I put the prompt for the LLM. Then here, what we are doing is that we help the LLM to categorize that specific prompt into different formats. Maybe we can we specify the type, which is a text, and we pass the text. We pass the text as a prompt, or I have done this because different Gemini LLMs receive human text in different formats. So I'm just giving the model different options to consider. So yeah, this is some. This is just a detail how I just pass the prompt, including the schema, to the LLM. I will show you this code in the WhatsApp group, so you can see it in detail, or you can reuse it for your application. And after passing that specific prompt for the LLM, we call the text function. This function help us to get the LLM response, which is that specific converted JSON file. So finally, we formalize it, and we return that specific JSON format as a return. So after we get the parsed or specific JSON format, we pass that specific parsed JSON format for a function called find by JSON. Maybe I can run this specific file if you need if you need that, maybe. By the way, if you have any question, you can interrupt and ask if there is any question. So let me run this specific file so you can see what the input and the output is. So we have in the main section, we have a list of a list of questions. For example, in this case, do I have a family who is a doctor in my network, and is there a nurse within 2 hops for me? So we pass these specific questions to the parse question to JSON function. So we can see how this function converted this specific question into JSON format based on the schema we specified. So text to JSON I. Okay, just let me pass to the second question, which is the find by JSON function. So this function just received the parsed JSON query and help us to get the result by pattern matching from our data, MeTTa data, and help us to return expression, or just return us who is whose connection. So let us see how I did this. So as you can see, I have imported Hyperon. I have imported MeTTa from Hyperon package, and I have initialized it here and imported the data.MeTTa file, which contains our graphical relationship. And we have a different relation categories, and we pass the specific .json data to this function, and we get the subject, the relation, the attribute, and attribute value. Then we convert this specific return values as pattern match query for the MeTTa. So as you can see here, I have formatted the question. If in our case, for example, if the question is any, for example, if the person is looking for a relationship with any, which means it could be a friend, colleague, family, or neighbor, or it might look for some specific relation. It could be a friend. So that's why we have a different condition here. So if it is any, we pass it just like this. Maybe I can show you in this test.MeTTa file to understand this specific format. So let's say we have a different relationship in this file, and for example, if you want to find any kind of relation with Alice, that is a person who is a nurse, but we are not dependent on specific. It could be a friend, colleague, or a family. So it's any relationship. So we can query the MeTTa using this kind of syntax. We have covered this in the morning session, so we can't say it's anyone, but we need the relationship with Alice and someone who is related with Alice, which this represent the person who is related with Alice. So this can pattern match anyone that has this kind of relationship with Alice. So it could be a friend, or it could be a colleague, it could be a family. So we are just pattern matching all of this relationship. Then finally, as a return type, we take those friends, colleagues, and we we query someone who has who is a nurse as a profession. So this specific query help us to find any kind of relationship with Alice, but who is a nurse. So that's what we are doing in this specific format. This could this works for any kinds of specific questions or query. But if we know that specific relation, we specify the relation here. For example, if you ask, I want to know who is a friend or a family. So this is simply the query. Then we return the query as a return type from this function. Then we can call this function inside find by JSON function. So this help us to return the result from our data. For example, in this case, let's hope it works. So in this case, for example, we have some kind of specific JSON, which is Alice. It could be any relationship, but we find a specific nurse who is a nurse. So yes, so this function is working. We passed it a specific JSON, and it returns a relationship. It returned the result. So it's saying Bob, Emma, and Helen are related with Alice with a specific profession, which is a nurse. We can check that by checking our data here. So Alice is related with a different person, but we can come here. We can see here Emma. Emma, Bob, and Helen are a nurse. I can't see Helen. Yeah, Helen. Here it is. So Helen is also a nurse, and they all have a relationship with Alice. We can see Helen here, Emma here, and another one, Bob. So we can check that the query is returning the correct result. So finally, we return this specific raw MeTTa outputs for the LLM again in our application, as I have told you before. So this is the raw result of the MeTTa expression. So we give it as a context for the LLM as a result here. So the LLM format that specific answer and return as an answer for our query. So this is uh, this is just a simple demo example how we can use Meta to build specific applications. So you can be like you can be creative and you can you can see how you can build applications using Meta. So before I close or stop showing my demo, is there anyone who have a question?
Um,
Okay.
I just have one question regarding Gemini. Can you explain more about how Gemini is used and what is the need of using Gemini here?
Okay. So as you have seen in the code, I have used the Gemini to help me parse the human query into specific JSON. So we used that JSON to convert to a specific meta query and get the result. I can just directly convert the human text into a meta query, but since Gemini or LLM is not aware of meta programming language or meta query, uh, it's difficult to get a correct answer from LLMs. So LLMs are good in general to convert the human text into JSON. So I used that JSON just to format into a meta query. Then I finally used the to help me answer human readable format, as you can see in the application. Uh, if you can see in my screen, can you see my screen? I think I have already.
Yeah, I can see it.
Okay. So the LLM is the one who is helping me to answer.
Got it.
Okay. Okay. I don't know why it's failing. Hmm. Okay, so the LLM is the one who is helping me to answer human readable in human readable context or answer.
Got it. Thank you.
Okay. Is there anyone? Okay, I don't know. I have been getting this similar error in the morning too. I think it's related with my API key. Uh, so I think yes, you can. I will show you this code in the WhatsApp group, and you can try it by yourself by setting up the project and by using your own Gemini API key. So this is the mini application I have built by using MeTTa. And is there anyone who have a question?
Uh, I'm having a question. Hello, this is Shivaji. Can you hear me?
I think I'm not hearing.
Can you hear me now?
Hello, Yapsra.
Yes. Hello.
Hello, Yaps.
Hello.
Yeah. Can you hear me now? Yeah, now I can.
Okay. Yes.
Yeah, a quick question. Is it like you are using LLM only for query part, or like
Hello, Yaps.
injecting data into the into Atom space?
Uh, I have already my data uh, in data.meta file. So I have my relationship in this file. You can say this is kind of a data or a database. You can use Meta as a database. So by just storing this kind of relationship in data.meta file, this will be stored in Meta. So I just use the LLM to help me convert the human text into JSON, and then I I convert that specific JSON into a meta query. Then the meta match expression or query helps me to find that specific answer. Then I will give that specific answer for the LLM as a context. So I'm not using to store the data into, I'm not using the LLM to store the data. I have already the data in .meta file. I'm just using to convert to question into JSON and return human readable answer.
Okay. Yeah. Yeah. Just I'm thinking how we can actually avoid using the LLM, and do you have like any other solution not using LLM to convert this? Maybe using some maybe sensor agents from Hyperon.
To specifically to do what?
I mean, to do this translation from text into JSON, so do we need to only use LLM, or is there any other solution from Hyperon, or some maybe agents which can actually translate this? Or
Yeah, for now there is no specific package found inside Hyperon. So yeah, I don't think there is any other package or option to convert a prompt to a specific JSON file. Yeah, so yeah, I don't think there are another option. Specifically, I don't think there is a package that converts
okay.
prompt to JSON.
Thank you, Franz.
Okay, anyone else? Okay, so what I want to add is that so this is just to show you or to give you kind of introduction how you can use MeTTa with your application. So for the in-person hackathon, we expect you to use MeTTa to integrate with your specific application and exercise how MeTTa can be used in different applications. We want you also to exercise MeTTa, how you can write MeTTa queries, what MeTTa is, and so on. In the previous hackathons we have done in India, we had different problem statements. We gave them to solve. So, I mean, can you see my screen? The specific document I'm sharing?
Yes, we can see.
Okay. So these are some example of specific challenges we have given them to work on, but it's open. They can also build their own idea using MeTTa and other systems. So on the in-person hackathon, we expect you to solve similar kind of problems using MeTTa. You can also work on your specific idea or project. So some of the examples, problem statements we have given to them is, for example, build a domain-specific FAQ chatbot with knowledge graph integration. This is one of the challenge. So the teams who have chosen this specific problem statement can build FAQ.
Hello, are you just showing the data .meta file, or are you showing any other files?
I'm showing a specific document.
Because we only see VS Code screen.
Oh, okay. Okay. Okay, can you see it now?
Yes.
Yes, we can see.
Okay, so this document contains different problem statements you can work on. So we have detailed requirements, what they are about and what you are going to build. These are just example applications you can build or using MeTTa. Yeah, you can integrate MeTTa on this kind of applications or problem statements. So one of the examples is building a domain-specific FAQ chatbot with knowledge graph integration. So as I have shown you in the previous demo, it's kind of similar with that one, but it's a FAQ chatbot with a knowledge graph. So this FAQ chatbot could be medical data or any kind of graph data. So I can ask that specific answer, or we have a set of FAQ or frequently asked questions. So the LLM helps me to answer that specific questions. But why we are using MeTTa is we have data, which is a knowledge graph. So that graph could be complex. It could contain complex relationship. So we use MeTTa to extract specific answer, or we use MeTTa to query specific answer from our knowledge graph using a match query or match statement. We can also write our own functions to get that specific answer from the knowledge graph. So the rest of the application is your backend, LLM, and so on, since it's a chatbot. And we have a similar other problem statement, optimal flight route finder, which helps us to find the optimal flight route. Let's say we have a data that contain different flight routes between different countries. So this one is also, you can also use MeTTa on this to build this application. We have another statement, smart to-do task scheduler, and so on. You can, we share you this problem statement on the WhatsApp group, so you can exercise this specific problem statements. You can also bring your own idea and build on that. So these are the questions we used in on the Hack India hackathon. So you can also build this specific projects application, or you can also build upon your specific idea. So these are the things we expect you in the on the in-person hackathon when we meet after, I think it's kind of after a week. So this is just to give you an introduction about MeTTa and what you can do with it. So yeah, maybe as an exercise, if you guys don't have any additional questions, as you can see in the previous demo, I have limited my application to search connections or relationship in one depth, which are direct related relation with Alice. So you can extend this into more depths, like two, you can make it 3 and 4. So the chatbot not only find the direct relationship, but also it find other relationships or finds depth relationships. I hope you understand my question. Maybe I have built this using a Python, but as an exercise or as a challenge, maybe as I will give you as to use MeTTa. As you can see in the JSON to MeTTa parser function, after I get the JSON file, notice after I get the JSON, the converted JSON file, I just find the direct relationship, or I just write a direct relationship queries with the subject, which is Alice. But we can write a nested match expression, and we can also find other relationship. For example, let's say I want to know anyone who is in my connection who is a doctor. So in my data, for example, in Ali's case, we have Bob, but Bob might not be a doctor. So I get the friends of Bob, and I also find someone who knows Bob and who is also a doctor. So I don't only find that specific answer in my connection, but also in my friend's connection. I hope you get my idea. So I have actually tried to implement this using Python, just simply by writing a BFS function. It's a BFS breadth first search. If you have a CS background, I hope you know this kind of graph search. So let me show you the example. Maybe, I don't know, my API is failing, but JSON. So let's say I want to find not only direct relationship, but also more relations or connections. Yeah, it's not working for now. Maybe I should update my API. I don't know. I think it's expiring. It's expired already. So, have you guys get my idea or what the challenge is? Maybe for now, or maybe I can ask Rahul.
Yeah, I got the idea. So we need to look at going more depths, right? More than one.
Yes. Yes.
Yeah.
Okay. Maybe. Yeah, that's what I want you to try. Okay. Is there any additional questions I might answer? I will show you my code uh, on the WhatsApp group. I hope you guys are there. Have you guys joined the WhatsApp group?
Yeah.
Rahul, did you join?
Yeah.
Okay.
Okay. So, okay. So yeah, this is for this afternoon session. So yeah, if you guys don't have any additional questions.
So is there any specific group in the WhatsApp chat?
Yes, yeah, there is a group called I think you can ask the organizers and join the group, the WhatsApp group.
Okay. Okay. I mean, I see like there are 4 tracks. I mean, so in which group are you going to share this code?
Okay,
'Cause
I will share it on general, maybe.
okay, got it. Okay, thank you.
Thank you very much, our participant. Shiva, you have been here from the morning till now. Thank you very much. Rahul, you have been around. Thank you very much. Darlington, I see you. Thank you very much. You are coordinating things locally, and it's been great. Abdul and everybody on the call today, thank you very much. We expect to see you on Monday. Keep subscribing to the channels. We'll give you updates, and then take care of yourself. And then we'll see you on Monday. Thank you very much. Have a good day wherever you are connecting from. Thank you.
Yeah.
Bye.
Thank you.
Okay, bye everyone.
Bye.